Hi there, and welcome back to part C, or the final installment of our organic naming and drawing lessons. It's been a long journey to get here, but by now we know what all of those commas, dashes, numbers, and letters mean when we see them all mumbled up on the page together, and we get excited about drawing this big complex molecule. We've gone through different types of carbonyl compounds so far, remembering that carbonyl compounds have the C with a double bonded oxygen to it, or the carbon. So now, we left off with esters, we're going to jump into an amine. So an amine is a functional group that has a nitrogen bonded to a carbon. This changes the properties of it. Generally, they are basic. And again, just like anything, there's many different ways to name this. We're going to show how the nitrogen can be incorporated by using the prefix amino in this case. So we're going to see that in front of the parent chain. So we'll jump right into an example. Scanning from the right-hand side, I see this BUT, the but prefix, so I know that I'm working with a 4-carbon chain. All right, on carbon 1, there is an amino group. So let's do it from this side. And an amino group is just a nitrogen. So that's all that means here. Nitrogen bonded to something else. Now the nitrogen's not like a hydrogen. A nitrogen can form its own bonds, and it can form 3 of them specifically. So whenever we see the N in the name now, that tells us what's bonded to the nitrogen, and the numbers tell us what's bonded to the chain. So on the nitrogen, there is a methyl group. I'll just draw it facing down, and the other bond has to be saturated with a hydrogen. So a methyl group has 3 hydrogens. We'll saturate this, and then we'll do the line diagram as well. As always, if you'd like to try it yourself, pause it and do that. Okay, if you haven't paused that, we'll go to the line diagram here. There's our 4-carbon chain, right? The nitrogen comes off of the first one, so 1, 2, 3, 4. It's got its own methyl group on it, which we'll show down because nitrogens are trigonal pyramid. And we're not going to show the hydrogen, but it would be right down here away from the lone pair. So that would be our amine in this case. It's a hydrocarbon that has a nitrogen on it. Another way of naming that would be to put it on the end. So butane 1 amine, just like our other molecules that we've done. Notice how it's amine, not amino when it's on the end though. And we have to see this because these groups don't always have priority. Okay, so when it has priority, it's amine. When it doesn't, it's amino. So a primary amine is just like we saw. So we'll rewrite this for consistency. Butane 1 amine. That is a 4-carbon chain for butane. And on carbon 1, there is a nitrogen. Because there's no N, we would just saturate this with hydrogen as in this case. So nitrogen needs 2. Remember that acronym HONC? 1, 2, 3, 4. That tells us how many bonds each atom needs. So nitrogen has to have 3. So there's our primary amine. The nitrogen is attached to a carbon that's bonded to the rest of the chain, and the nitrogen only has 1 alkyl group on it. So primary amines will always have 2 hydrogen, if it helps to look at it like that. A secondary amine has 2 alkyl groups attached to the nitrogen. So this is like the first molecule that we drew. We're going to rewrite this just to see. So the first one written, it's not wrong. It's written if the amino group is not the priority and it's a side chain. The second one is if the amine is the priority. So the ending of the name is changed. And you notice we just dropped the E on butane for that. So we've got our 4-carbon chain. Let's put this as carbon 1 here today, just to get used to moving things around. And on the nitrogen, we are going to have, because we're coming from that way, we'll do it like this. We're going to have a methyl group on it. So there's 1 hydrogen on a secondary amine and 2 alkyl groups. Lastly, a tertiary amine is just a hydrocarbon that has a nitrogen and 3 others attached to it. So to rewrite this as the main chain, say dimethyl methanamine. Now I don't need a number here because there only is one carbon, but if I needed to, I would put it between the methan and the amine part right there. So we'll start with a one carbon chain attached to a nitrogen, attached to two other carbons for the dimethyl group portion. And you could see you could also call this trimethyl amine. There's a lot of different naming systems we can use, but the one we've been consistent with is IUPAC. So there's the molecule for that, AX3E, just to bring that back. So it's going to be trigonal pyramidal. And if I drew that out in 3D, just for fun, and then each of these carbons would be tetrahedral. So they get pretty bulky. It's going to look like almost like your lungs, where you have these branching effects. So you have the nitrogen branching off here to a tetrahedral shape, branching off to a tetrahedral shape, and then another one from there. So they get pretty bulky as they go. So the main takeaway is when you see N in front of an alkyl group or a branch, that just tells you to put it on the nitrogen. Next up, an amide. An amide is similar to an ester in the fact that there's a nitrogen bound to a carbon that has an oxygen double bond. So in general, this one will have the C double bond O, the carbonyl group, and a nitrogen instead of an oxygen. So it's similar to an ester. That's its general formula there. So if we draw methyl ethanoate from the previous one, okay, two carbons, O8 tells me that it's an ester, so I've got a double bonded carbon with an oxygen there. And on the other side of that, I've got a methyl group. Okay, so this is our ester. Now on the comparative side, if I look at ethanamide, okay, I've got ethane again. Amide tells me, like above, I've got a double bonded oxygen, but to a nitrogen this time. And on the nitrogen, I've got a methyl group. So just to finish off this structure, I think it's nice to see these side by side to be able to compare. So once you know what everything means, it becomes easy to build a molecule. The name has all of the information in it, so you take it step by step, and hopefully that helps. So to name an amide now, for as an example, we start off by looking for the longest carbon chain. Okay, so pause this and make sure that you've tried it yourself. And on the end, we're going to put amide instead of, like with a carboxylic acid, where we put oic acid. And that becomes carbon number 1 if there was future branching. So in this case, I've got a 4-carbon chain. That's going to be butane, because there's all single bonds. Even though I've got that carbonyl group, right? I've got a carbon double bonded to an oxygen and a nitrogen. So that is an amide. And amides will all, again, just like carboxylic acids, be on the end of a molecule. And that's because they occupy 3 bonding spots of carbon. So when I put those together, I drop the E, and I'll get butanamide. So we don't need to put butane 1 amide in this case, unless there's a really complex functional group here. Okay, so that ends that example. If you're wondering what that would look like, if I had a molecule where I had an amide group on one end and a carboxylic group on the other end, well, now I've got something called an amino acid for those biology buffs and biochem purists. But to name it systematically, like we've been doing, the carboxyl group still gets priority. So in this case, this is carbon number 4. This would be 4. And we've got nothing on the nitrogen there. Oops, sorry, we're going to put this in here. It's going to be butane 4. Amide, we're going to drop the E from there. Oic acid. Sorry for the pause in between there. So it gets a little more complex. Not going to test us on anything like this, but always fun to see where the complexities go. In practice, if this was an amino acid, right, we would only have 1 carbon in between, but By the letter of the law, this is one. It's just not one that's essential to the body. There would be one carbon in between there for that. Okay. So focus on this part up here, butanamide. This summary chart, you're going to want to draw one of these for yourself where you talk about the name of the functional group, what its general formula is, and the ending. And you don't need to copy down this, but it's more for interest, right? You can see where these different types are for, but you also want to know when it's a prefix. So for example, not all of them do. You can go back earlier in the lesson for it, but an alcohol group, for example, I'll do it on the next slide here. An alcohol group is an OH. It ends a molecule with OL, or if it's a chain, it's hydroxyl. So be able to generate one of these columns for each functional group. You might have to do a little bit of research to fill in these two columns here. That's okay. Spend the time to do it and then practice. So this concludes the functional groups and the naming and drawing of organic molecules. Spend some time with this. We're going to take a few days to really consolidate this. We won't only be drawing complex molecules. We'll be drawing simple ones as well, because we'll work with all of these as we head into different types of reactions.